Okay, now we're going to talk about how to calculate a present value in Excel using the present value function. It's really similar. The good thing is these functions all work pretty much the same. It's just a matter of which variable you're solving for. So am I solving for present value, future value? Am I solving for an interest rate? I can solve for almost any of these variables. It's just a matter of which one I'm actually trying to look for right now. So, and how present values work is kind of the opposite of a future value. So if you want to pause this video and build this table here, this is the one we're going to use. So let's say that I am going to receive $100,000 in 15 years. I want to know what is the value of that payment today based on a discount rate of, let's do 9%. Okay, so what I'm looking, first thing, let's just get a little grasp on what we're trying to do here. So if I'm going to get $100,000 in 15 years, I want to know, okay, if that were money in my hand today, what is the value of it? Assuming that it grows at a rate of 9%. So I'm kind of doing a future value backwards. I'm saying, what is it worth now? I know what the future value is. And discount rate, the only reason we use the term discount rate rather than interest rate is because of the direction we're going. We're discounting it backwards. It's still an interest rate. It just is, since it's in reverse, it's called a discount rate rather than an interest rate. So the annual interest rate is 9%. Number of periods, again, we'll calculate it like we did in the prior video. If you watched that, we're going to take the compounds per year times the number of years. Payment, again, we're not going to use that on this one. Payment represents if I instead said, what's the value of the payments of $5,000 a year for the next 15 years? That would be a regular payment at a regular interval. So that would be the payment function, which we'll talk about in a future video. For now, that's 0 because I'm just talking about a single amount. The present value is what I'm going to look for. So I don't want to put anything there for now. The future value is that $100,000 in this particular problem. The type is, it's getting paid at the end. So I believe that's a 0. Number of years is 15. And I'm going to assume this only compounds once per year. And remember, my interest rate per period, I'm going to take my annual interest rate divided by my compounds per year. So 9% interest rate. So now I can write my present value function equals PV, open parenthesis. I'll open up the function box to make it a little easier to see. Rate, but it wants the interest rate per period. So I want to make sure and use the interest rate per period. In this case, it's the same number either way because it's only compounded one time per year. But like I said, if it was compounded monthly or semi-annually or quarterly, then I would make sure, and it says it right here, we would divide it by that. So I'll use this interest rate per period. Number of periods, my input is right here. My payment is right there for 0. Future values, $100,000. Type, payment at the end of the period, so type 0, which I've got here. So what I can say is that, and I'll highlight the calculated cells again. I believe that's it. So what I can say is that if I had, and I can check this math, by the way, by doing a future value with it. So what this means is that if I put $27,000 into a bank account right now that had an annual interest rate of 9% in exactly 15 years, it would be $100,000. So if I want to go back, if you watch my prior video and built this future value one here, I could go back and check that math to make sure this is working out correctly. So if it is, my annual interest rate is 9%, payments 0, future value is what I'm looking for, present value is what I found, 27,453.80, and there will probably be some rounding here, so it might be a little bit different. Type is a 0, number of years is 15, compounds per year is 1. You see it's off by 2 pennies, but effectively I checked my work and found that that is exactly the case. $100,000 future value. 15 years from now, if I discount that back to its present value, it's $27,453.80. Also, I could say it a different way and say, if I invested $27,453.80, and I had a growth rate of 9%, in 15 years, it'd be worth, and like I said, rounding, there's a couple pennies, but it'd be worth $100,000 15 years from now. And that is the present value calculation in Excel.